My name is Michael Coombs, and for my SME project today, I chose to talk about the future of data visualization with virtual and augmented reality. To start off, I'll explain a bit about what exactly data visualization is. So data visualization is the process of displaying information in a visual context, and it has many different formats in which it can be presented, such as charts, graphs, maps, infographics, and dashboards. So why is it important to use data visualization? The main reason for using data visualization is its ability to help users identify patterns and trends in their data. It also provides the ability to analyze data better, increase the speed of decision making, and make better sense of large or complicated data sets. So when creating visualization for your data, there are a few key factors to keep in mind. So it should have a clear purpose and audience. So this might determine which perception of your data that you're trying to focus on, whether that be sales of a product or reviews of a product, depending on who you're presenting the data to. The next is which type of visualization you choose for your data. So depending on what type of visualization you choose, you might make your data easier to understand, such as using a map to show data comparisons across geographical regions. The third factor to keep in mind is the use of labels to clarify your visualization, but without creating clutter. The use of color to highlight important information or show comparisons. Avoiding misleading visualizations, such as two data points having the same color when they should be compared with different colors. And lastly, the sixth key factor to keep in mind when creating data visualization is to keep your visuals simple rather than overcomplicated. So you might already be working with a large and complex set of data, and the point of visualization is to make it easier to understand and process, so to overcomplicate the visualization would kind of defeat the entire purpose of it. Something to consider when dealing with data visualization is the privacy of the data. Data can be seen as sensitive information for many reasons, as it may pertain to personal information of data subjects or confidential company information. So that's where privacy-preserving data visualization comes in, which is defined as the control of risk disclosure by applying permutations to real data points. So this might look something like a code or phrase which represents a data point without disclosing its true name. So why is it important to preserve privacy in data visualization? Like I mentioned, this is important to prevent disclosure of personal information of data subjects, data owners, and to protect data sharing policies within an organization. Using privacy-preserving methods may also save time, resources, and risk. So rather than designate time and resources to have someone perform a risk evaluation on the data, it can be covered by applying these permutations. Within our field of cybersecurity, we can use data visualization to improve our ability to maintain and track our security. So why is data visualization important to cybersecurity? Well, with data visualization, we are able to uncover patterns of potential threats. This will help build an early warning system for cyber attacks. We are also able to illustrate threat activity to isolate the scope and severity of an incident. So when using data visualization for cybersecurity, we have four main metrics to focus our data on. The first is our time to detect and time to response. This data will help illustrate the time taken between identifying an ongoing threat and its containment. With this data, we can better determine severity of particular attacks and how long they will be affecting an organization. The next metric is time to patch. This data will document the time it takes for an organization to patch any vulnerabilities they may have. The third metric to focus on is the total volume of data being transferred on a network. This is important to document as employees operating on an organization's network may be downloading software, videos, applications, and more. This can potentially lead to threats gaining access to the network through malware and other cyber attacks. So having this metric documented is critical to identifying users who may be leaving an open door to potential threats on a company's network. And lastly, the fourth metric to focus on is third-party network attempts. This will help to identify malicious activity or potential breaches. By creating a mapping system, we can see all the users along their access points into the network to help identify vulnerabilities. So what is augmented reality? Augmented reality augments your surroundings by adding a digital element to a live view. This type of technology can present us with virtual objects and information in our field of vision. We can use AR to enhance any natural environment or situation to offer an enriched experience. Some common examples of augmented reality technology that most of us have heard of or maybe even used. Snapchat and its filters, which augment your face or surroundings for pictures and videos. If you've ever used the Amazon app, you may have noticed a button on some product pages that says View in Room, and then basically you're presented with Amazon's AR feature, which lets you see what that product would look like in the room you're standing in. Another is the use of AR glasses. And while I don't think this picture accurately represents the type of glasses on the market today, I think this product isn't far off and the development for this is definitely underway. And lastly, I think most of us have at one time played the game Pokemon Go, which actually uses AR technology to digitally depict Pokemon in a live view through our phones. So what is virtual reality? So different from how augmented reality puts digital elements into a natural setting, virtual reality actually creates a completely immersive experience that replaces your real-life environment with a completely simulated one. Some popular examples I came up with for virtual reality were Horizon Worlds. So in this you can collaborate with others to create other virtual worlds. And here are a few popular games that are played using virtual reality. I actually just tried the Vader Immortal game for the first time a few weeks ago, and it's pretty awesome. Now you can imagine how many possibilities there are when you consider merging the art of data visualization with the growing technology of augmented and virtual reality, and that's what we're going to explore from here. So what is AR and VR data visualization? With AR and VR technology, data in the form of charts, tables, and more can be displayed in front of, behind, above, or side to side of the user, either in their natural environment or in a completely virtual one. This also allows for better interaction with datasets in a three-dimensional visualization rather than a two-dimensional screen. And it allows for more features of presenting and manipulating the data. So why would we use AR and VR for our data visualization? Firstly, having the ability to explore datasets in multiple dimensions will unlock new ways to analyze our data. New ways to visualize and see data points interact together will lead to possibly finding more patterns and trends. This can also provide more immersive ways of presenting data. So rather than sharing a file across multiple computers or presenting data on a smartboard, with AR and VR, you can bring the data to life and get everyone involved in analyzing and understanding the data in front of and around them. This form of presenting is also helpful when someone has to present complex or large data sets to people who have no prior knowledge of data analytics. In this scenario, an immersive virtual environment or object might help to understand or stay engaged with the data. And lastly, a reason we might choose to use AR and VR for data visualization is the interactive features. This could be manipulating and interacting with the data in ways such as touch, speech, proxemics, gestures, gaze, or wearables. So some examples of softwares and products which let us use AR and VR for data visualization are IBM Immersive Insights, Microsoft HoloLens, Llama Zoo, and what's probably the most popular by Meta is the Oculus Quest. So the two products here would be the Microsoft HoloLens and Oculus Quest, and then IBM Immersive Insights and Llama Zoo would be two softwares that you can use to kind of manipulate data and create those charts and graphs. So why would someone use augmented or virtual reality for data visualization in cybersecurity? Firstly, it can be a lot easier to understand large amounts of data, which is already a common occurrence in the world of cybersecurity. With so many different ways to project, compare, present, and manipulate data, with AR and VR we can take large amounts of data and fit them into an environment or scalable object designed for ease of interpretation. We can also find more patterns with AR and VR, which is a key factor in using data to predict and prepare for potential cyber attacks. With this technology, we can present our data in many different ways and view it from many different angles. This allows the possibility to find new patterns and trends in information that may have looked totally different on a two-dimensional screen. And like I mentioned earlier, this type of data presenting can be a lot easier for non-data scientists to understand. This can be important when you are in charge of maintaining security for an organization or company, and you have to explain your data to a manager or owner who has no background in data. Lastly, I would choose AR and VR for my cybersecurity data visualization because of its collaboration abilities. Rather than one person presenting and manipulating data, a whole team can work seamlessly together while taking advantage of the immersive elements of the data. So for the future of data visualization in AR and VR, I think we will see an exponential increase in its use cases and abilities as it is an emerging technology with a lot of upside potential. So a few things I think we'll see in the near future for this is it becoming more accessible and common. Right now it's still in its early stages of development and it's not something we've all seen or used, but I think that will start to slowly change as it becomes a more prominent technology, and maybe in 10 years it will be the standard for data visualization. Another feature we will see is improved wearables. Whether it's gloves, glasses, or anything else, I think we will see the wearables of this technology get lighter and less bulky. We will see an upgrade in the quality of the virtual environment and objects. Just like we've watched video game graphics reach new heights in the past decade, I think we're about to see the same thing with augmented and virtual reality. And lastly, I think we will start to see new accessories come out that will make our data analyzing feel even more immersive and seamless. Eventually, this may be the simplest way to project in any type of data in any scenario. So to summarize briefly what we covered today, creating data visualization and keeping in mind the 6 key factors to a clean and concise visualization. Augmented reality versus virtual reality and the difference between a technology that creates an entire virtual environment versus virtual elements created in a natural environment. What is AR and VR data visualization and how it changes the game in terms of what visualizations can do? And why choose AR and VR for cybersecurity and how its features can improve the quality of your threat protection?